So let's talk about conic sections. Conic sections are shapes described by the equation ax squared plus by squared plus cx plus dy plus exy plus f equals 0, where a, b, c, d, e, and f are any real numbers. We are going to assume that e equals 0 since all it does is rotate the shape. So we won't have the xy term in the ones we're going to do, just because it doesn't do a lot for us besides rotate them. So let's talk about the different situations we have. This basically, a lot of our second order polynomials or first order polynomials come from this equation. If a equals 0 and b equals 0, then what we have is we'd end up actually having cx squared, cx plus dy plus f equals 0. So if you look at this, this is obviously a linear equation. So a line. So the graph of that is a line. So that will show you that you can get any line from this set of conic sections by this equation. So let's say a equals 0, but b is not 0. So that means we end up with by squared plus cx plus dy plus f equals 0. So if you look at this, you're going to have an y squared, but not an x squared. So this is going to be a parabola. This one opens left or right. If b equals 0 and a is not 0, then you end up with ax squared plus cx plus dy plus f equals 0. So notice in this case, what you end up having is a parabola. So it's parabolic. So it's a parabola. And it opens up or down. If b and a equal each other, but neither one is 0. So you still have them, but they're not 0. So you're going to have ax squared plus by squared, but b is the same as a. So we can actually call it ay squared plus cx plus dy plus f equals 0. So this shape, if you think about it, you could actually take the cx and put it with the ax squared and put the dy with the ay squared and complete the square. You're going to get a circle. So this is just a circle. What if a is greater than 0 and b is greater than 0? So they're both positive, but a is bigger than b. So in other words, they're not equal this time. So you're going to have ax squared plus by squared plus cx plus dy plus f equals 0. This shape looks an awful lot like a circle, except that because you've got this ax squared and by squared and not the same, you get a squatty circle. So this is an ellipse. If a is bigger than b, then your x squared term is the bigger term, and then your y squared term. And so we want to see what does that look like. And if you're not positive what it looks like, you can actually go over to Desmos and actually plot it. So let's actually try plotting one. Let's try plotting 5x squared plus maybe 2y squared. So in this case, again, a and b are both positive. Plus, I don't know, let's do just 5. We don't need to do a real big thing here. We don't need the x and y term equals 0. Actually, we'll just make it equal to 5. There we go. So here the x is positive, is bigger than the y. So the a is bigger than the b in this case. And notice you've got elongated in the x along the y-axis. So that's what we can say that one does. So we can say that this was an ellipse along the y-axis. Oops, sorry, let me make this look like a long. If A is greater than 0 and B is greater than 0, but this time B is bigger than A, you're going to have the same equation. So you're going to get the exact same shape. You're still going to have an ellipse. But in this case, it's going to be along the x-axis. Now, if A is bigger than 0, but B is less than 0, you still have that same equation, but now your y-squared term is negative. And the shape of this is what we call a hyperbola. And again, you got to decide, is it going to be opening up or down, or is it opening left or right? So again, we're going to go over here to Desmos. We'll take a picture at the graph. And actually, all I got to do is just make the B negative. And you can see if the B is negative, which means the y-squared term is negative, it opens left and right. So we can come back over here. And it's in a hyperbola that opens left or right. And so if A is less than 0 and B is positive, so they're opposite signs again, but now the x-squared term is negative, you're still going to be a hyperbola, but it's going to open up and down. All right, the next thing I want to mention is that sometimes there's occasions where the equation just can't be true. If you were to take your equation and you were to try to complete the square with the x squared and x term and the y squared and y terms and complete those squares, you'd find out that you've got something squared plus something squared equals a negative number or equals 0. And so because the terms don't add with the f correctly in such a way. And if that happens, then you either have an equation that goes to a point. If it equals 0, then it's become a point, or it's just a point that's not possible, an equation that's not possible. So that does happen on occasion. So the next thing to talk about is polar coordinates. Every point in the rectangular coordinate system can be described by an x and a y value. And we can also describe those points in the coordinate system in a polar coordinate system by an r and a theta value, where r is the distance from the point to the origin, and theta is the angle from the positive x-axis to the line from the origin. And so remember, this direction counterclockwise is a positive angle. Clockwise would be a negative angle, and there you have that. So let's see if we can figure out what these things are. So if we notice using right triangle trigonometry, opposite over hypotenuse is the SOHCAHTOA is sine. So opposite over hypotenuse would be y over x over r is a sine. So that means y is equal to r sine of theta. Adjacent over hypotenuse is cosine, and that's your x. So x is equal to r cosine theta. So if you know your polar coordinates, you can go to rectangular coordinates quite easily by just using this relationship. The other relationship, if you know your rectangular coordinates, you want to go to polar coordinates. Remember, you got x and y and r. This is a right triangle. So you've got x squared plus y squared equals r squared. And then you also could think about the angle. You can use these to find the angle, but the problem is you're using rounding and you could have rounding errors. We try not to do that. So if you think about it, we have opposite and adjacent, that's tangent. So the tangent of your angle would be the opposite over the adjacent, x of y over x. And so you just take the inverse tangent. Going from polar to rectangular is pretty easy. You just use this formula. Going the other direction gets to have a little bit more challenge. So let's go ahead and do converting from rectangular to polar coordinates. Let's take the point 2, 2. I'm going to first make it into the, find the r value. So r squared is going to equal x squared plus y squared. I do need to be told that this is rectangular coordinates because you don't know just by looking at them that they're rectangular. So you have to be told these are rectangular coordinates and we want to go to polar. So r squared is equal to 8. So r is therefore equal to plus or minus the square root of 8. So you have to think about which one you want to have. Normally we let r be the positive one, but there are occasions where people do let r be negative. So you got to think about that case. So we're going to let it be the positive one, and I'll show you kind of what we're looking at. Now let's try to find the angle. So the tangent of theta is equal to 2 over 2. So theta is equal to the inverse tangent of 1. And the inverse tangent of 1 is pi over 4. Now remember, that's your reference angle, but 2 happens to be in the first quadrant. It happens to be right here. So this is your angle. That's your pi over 4. And your radius is the square root of 8. Notice your radius is positive in this case because we're going from the origin to that point. And your angle is pi over 4. So that one wasn't too bad. Let's try another one. Let's try -4, 3 is my rectangular coordinates. So now I want to go to what they are in polar coordinates. So my r squared would be -4 squared plus 3 squared. So my r squared is going to equal 25. So r is equal to, again, plus or minus 5. Usually let it be the positive one, but there are occasions where you can be negative. Negative just means that you're thinking about taking the r this way, in which case you have to change your angle to get you back over to here. You couldn't use pi over 4. You'd have to use a different angle to get the right value. But we're going to usually let it be positive. So here's my r is 5. Again, my angle, my tangent of theta would be -3 over 4. So my theta is the inverse tangent of -3/4. Sort of, that's what theta is. Let's go find out what that is. So I'm going to take out my calculator to find out what that is equal to. And so I'm going to take the inverse tangent of -3/4. And I would like an approximate for that. And so I end up with that it's approximately equal to -0.644. And that's radians. I didn't do it in angles. I did it in radians. One of the things I want to point out here is that that's actually the reference angle. So think about this. -4/3 is actually right here. But the inverse tangent is in the first and fourth quadrant. So this angle right here is the -0.644. So I actually need to get the reference angle, which is actually +0.644. And that's this angle here. In the third quadrant, it's that angle from the line to the x-axis. I want from the positive x-axis to the line. So I need to subtract that from pi. So I'm now going to take pi minus that angle. And make sure you're doing it to the, made a mistake on my calculator, sorry. So we're going to do that angle plus pi. I got to find pi on my calculator. Don't know where pi is on my calculator. I'm sure it's somewhere, but I can't find it this very second. So I don't want to waste time trying to find it, but you know what I mean. So you're just going to take this angle. Your theta is actually going to equal pi minus the 0.644. Let's do one more. Let's do -2, -1. So again, what I really should think about first is where is -2, -1? Well, that happens to be in the third quadrant. So when I go to do this, I need to remind myself that's where I am. My r squared is going to equal -2 squared plus -1 squared. So that is 4 plus 1 +5. So r is equal to the square root of 5. And then I need to do the inverse tangent. So theta is the inverse tangent of -1 over 2, -2. So when I think about this and I go to do this, I am going to do the inverse tangent of -1 divided by -2. And that gives me 0.464, let's say. But that's actually your reference angle. So again, that angle is going to be a positive angle in the first quadrant because that's the reference angle. So that really is what you have. That means this angle here is the reference angle, and you need to add pi to that to get your actual theta. So theta is actually pi plus that reference angle. And so then you go find out what that is and approximate what that value is. Lastly, I just want to make a comment. Let's go ahead and look at plotting this. So let's actually just try a fairly easy one. Let's do the first one, which was 2, 2. This is actually a polar graph. So this is a polar coordinate plane. So here, instead of being where you're measuring off over 2 and up 2, you are looking at the fact that you've got radius here of 1, radius here of 2, radius here of 3, 4, and so forth. And then you've got your angles here. Here's whatever these happen to be. This one happens to be pi over 4 or 45 degrees. So the red line here is pi over 4. This one's pi. This one's 3 pi over 4. I'm sorry, this is pi over 2, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2, and 7 pi over 4, and then 2 pi. And then you've got your other angles in here you can look at. So we know that this one is going over 2 and up 2. That looks to be about here, right there. Looks like that's what that point would look like. But I want to think about it as when I go to plot this, I'm on the line, my angle is pi over 4. So that's this angle here, measured up there is pi over 4. And I'm going to come out to a distance of square root of 2. So distance of square root of 2 puts me about here, because that distance along this radius, as I'm moving along, that radius is pi, the square root of 8. So there is the point, square root of 8, pi over 4.